Welcome to class number 4 of our CSE 104. And we're going to take up where we left off last week, talking about the flood. What effects did this cause on the earth? We mentioned how that probably right after the flood was over, the oceans were actually smaller. This would expose enormous amounts of land that currently are underwater, called the continental shelf. I want you to look here at the map. Between England and the United States, or between England and Europe, is the English Channel. It's about 30 miles wide, and yet it's only about 150 feet deep, I believe, at the deepest point. 150 feet out of 30 miles, you realize that's nothing. So we sometimes look at the maps and say, wow, that's blue, therefore that's water. Yeah, that might be true, but that doesn't mean it's very deep water. Sometimes it's very, very shallow. In between Alaska and Russia here, you can see underwater land bridge that's just absolutely enormous. And all you'd have to do is freeze a bunch of the water and stick it on the poles as huge ice caps. If the ice caps were larger, the oceans would be smaller, obviously. If the oceans are smaller, then the land masses are not only bigger, they're all connected. This shows where the land bridge would be if the ocean levels were lower a little bit. So we have two parts to the ocean, basically, or it depends how you want to count it, but we have the continental shelf, then we have the continental rise, and then the deep part called the abyss. Florida was probably about 1,000 miles wide. If you lowered the water just a few hundred feet, you could almost walk to Cuba. And then from Cuba, you can hop over the creek and go to Mexico. And that ditch between Cuba and Florida may have not existed at all. Let's suppose the oceans were lower after the flood. The Atlantic Ocean is filled in, but the Gulf of Mexico may be totally dry. It may be just a low place. Once the water gets high enough to go over the top, then it'll erode that canyon. So the ditch between Florida and Cuba may actually be an eroded canyon, underwater canyon. There are some enormous canyons. Look up where Boston is and go south to New York and look out into the water. You see some huge canyons. The Hudson Canyon. Can you see that on the map there? There are underwater canyons that are enormous. Well, how did the Hudson River cause that? If the beach line, though, was out a few hundred miles, then the Hudson River would be flowing way out there. And as the river comes up, the old canyon becomes covered up, becomes part of the ocean. And then erosion becomes much more difficult. The Gulf of Mexico is probably real tiny right after the flood. This would be my theory, that the oceans filled in, and the reason we have a continental shelf is because of the ice caps melting back, which we'll get into in a minute. So you can see where New Orleans is there. South of there, you can see the Gulf of Mexico has what's called the Mississippi Cone. There's enormous amounts of mud being washed out there all the time, about 80,000 tons an hour washing into the Gulf of Mexico from the Mississippi River. Well, of course, we covered in seminar part 1 how that this is an indication that the Earth is not billions of years old, because the Gulf of Mexico would have been full of mud. If you ask evolutionists, they'll say, well, there was an ice age 35,000 years ago, and there was another one 100,000 years ago, and they've got like 6 or 8 ice ages. They argue about the number. Ask them, how do you know there was an ice age 80,000 years ago and 30,000 years ago? How did you pick these numbers? They picked those numbers from factors like this. For instance, the erosion rate of Niagara Falls caused them to pick the number for, 30,000 years ago for an ice age. And the filling in of the Gulf of Mexico would cause them to pick the number to say, oh, well, that was because 100,000 years ago there was another ice age. That's why they're getting those numbers, is from these features. When I was in Fairhope, Alabama, which is right on the Pensacola side of Mobile Bay, I asked some of the folks there, I said, how deep is the bay out there? Because there were some people out there going out in boats. They said, well, about the deepest place is about 7 feet. I mean, all the way across that huge body of water, 7 feet deep, this deep. When they have a hurricane, two things happen in a hurricane. There can be a tidal surge where the wind is blowing one direction so much it pushes the whole water pushes up. If we got a big pan of water and blew real hard on one end, we could blow all the water up and make it sloped just from the air pressure. Hurricanes do that. They push water in. It can come up 15 feet or 30 feet even in a tidal surge. But before that happens, if the wind is blowing offshore, you have the opposite effect. There have been several times when Mobile Bay was empty. There was no water in it. Got to figure what they call it. It's not a tidal surge. It's the opposite of a tidal surge, but there's probably a name for it. Same thing with Pensacola Bay. Very, very shallow. Lake Okeechobee down in South Florida. You can see that dot, that huge blue dot there in the central part of South Florida. It's only 6 feet deep. Giant lake. Very, very shallow. So it's a little deceptive to look at maps and say, you know, because it's blue, it's water, therefore it's all the same. No, they're definitely not all the same. So why do we have a continental shelf? How did the oceans fill in? Where did all this extra water come from? We're going to cover that here tonight on more about this flood in what I call the Hovind theory, so nobody else has to take the blame for this. The ice caps would be huge for several hundred years right after the flood. Then they would slowly melt back. There have been cases where they've seen icebergs, you know, break off, then float around for 5 years before they melt. There's been serious consideration of getting icebergs and dragging them down to water, Sahara Desert. The problem is the cost of dragging it down there. You know, take an awfully big boat and a whole crew of guys and a lot of gasoline, and it's just not worth it. You know, it's cheaper to go raise your crop somewhere else currently. But if the price of food quadrupled, people might look at that a little more seriously. Well, now it's, you know, it's feasible to do. The flood is right here on this timeline. Noah's son Shem, born about 100 years before the flood. After the flood, had a son named and he named him Arphaxad. Arphaxad begat Selah. Selah begat Eber. Notice all of these guys are living over 400 years. Then you get to Peleg, and he only lives 239. What happened in the days of Peleg anyway? Something changed on the earth. So, here's my theory. During the last few months of the flood, the unstable plates of the earth, which had been fractured, would shift. I mean, if the earth's crust was cracked up like an eggshell, and these pieces are floating around, someplace tilts up or tilts down or slips up and down, if the thin spots sank down, the water would rush down to fill in the hole, causing Grand Canyon in a few hours on the way, or a few weeks at the most. And also, the other part that lifted up would become the mountain range. Thin spots sink down, other places lift up, like a waterbed. You push down somewhere, someplace else goes up, or a water balloon. The runoff would cause huge canyons in a hurry. The earth today is almost perfectly smooth for its size. The earth, they say, the biggest mountain we know of is Mount Everest, 5 miles tall. Well, on an 8,000-mile Earth, that's 0.0625%. Cue balls have bumps bigger than that. If you shrank the Earth down to the size of a cue ball, it would be smoother and rounder than the cue ball. Even though, you know, Earth has these giant mountains, they're insignificant compared to the size of the Earth. At this distance, you can't even find Mount Everest or the Rocky Mountains. You couldn't find them. This runoff, then, that would cause canyon features to be formed very quickly while the sediments are still soft. You go places out west. I've flown out west many, many times, and I just never tire of looking out the window of the airplane at these huge areas where it almost never rains, and yet it's obvious there's been enormous amounts of erosion here. I think all this stuff probably formed quickly. When I was in is it Lompoc or Lompoc? Lompoc, okay. I didn't stop and ask a local native, but you guys lived right by there. I was driving down this new highway they just put in. Been there a couple of years, I think. And apparently they didn't get the sod planted in time, because off to the side I saw some erosion. So I walked up and took some pictures. As I got closer, I realized, man, we have a miniature Badlands. Probably after 1 or 2 rainstorms. All you need for erosion is lots of water and soft sediment. The softer the ground, the faster it erodes. Common sense. Here's Bryce Canyon. Tremendous erosion marks with these. The reason these pillars are sticking up is because there's a hard rock on top. If you have a hard cap on top, the water hits it and erodes everything beside it, but it can't erode right under that hard cap, unless, of course, it gets enough that it falls over. You know, did you guys stop in Colorado Springs and see Garden of the Gods on your way back? Have you seen that? My aunt lives there in Colorado Springs. We used to go there a couple times a year as a kid, all my life, you know. Been all over those Garden of the Gods, climbing on those rock formations, which very obviously were, I think, from the flood in the days of Noah. The Mississippi River basin is gigantic. This whole purple area drains into the Mississippi River and comes out in New Orleans. And by the way, the Mississippi is trying desperately to change its course again, and they are spending a fortune to make it not change its course. They have giant projects to prevent this from happening. But Chicago is only 600 feet above sea level. 2 football fields. You know, from here to the stop sign, that's the elevation of Chicago. Above Pensacola. Not much. Now, this 600-foot drop the Mississippi River goes through, it takes the Mississippi about 920 miles to drop from the equivalent latitude of Chicago down to New Orleans. So it's going to drop 600 feet in 920 miles. Not much. It's dropping 8 inches every mile. Because the Mississippi is flowing on such almost level ground, drops this far in a mile. Gravity pulling it down. The Mississippi River loops back and forth because of this low gradient, it's called, meandering. If you built a dam across Grand Canyon, of course, a giant lake would form. If you could build a dam across the Mississippi, you'd have to cover, you know, probably all the state of Louisiana, be an awfully big dam. But if you built a 600-foot high dam across New Orleans, Chicago would be on the beach from a giant lake that would form. That whole purple area would be underwater. Grand Canyon, as we mentioned, is obviously a breached dam. Textbooks always say it took millions of years to make Grand Canyon. That simply is not true, okay? The top of the canyon is about 4,000 feet higher than where the river enters the canyon. Rivers do not flow uphill. No way that river made that canyon. It had to be formed quickly as a lake overflowed, okay, a spillway. Grand Canyon is a washed-out spillway, basically. And here's the map that they give out at Grand Canyon. If you go there, this is the map they'll give you to get around. The river enters the canyon 2,800 feet above sea level and flows south and then over to the left, to the west. The canyon rim is over 6,900 feet, up to 8,500 feet in places. At that point, the river is only 1,800 feet above sea level. So since the top is higher than the bottom, and the river runs through the bottom, and the top's higher than where the river enters the canyon, and rivers don't flow uphill, then that river did not make that canyon. It's just common sense. There's a picture of Grand Canyon. I just flew over it a couple weeks ago for about my 9th time, I guess. I just never tire of looking at that thing from the air. It's absolutely gorgeous to see. But basically, it's wasted real estate. What can you do with it besides look at it? That's about it, you know. I was in Idaho, and I stopped at a bridge and took a picture of a massive canyon. This little creek at the bottom flows into the Snake River, where Evel Knievel tried to jump across, you know, with his motorcycle. The Snake River, there's the Snake River there. I don't know if that's the place, but near there he tried to jump across with his motorcycle. Stupid. See, the rivers, though, are characteristic. You can tell things about the history of the river a little bit by the shape of the river. This textbook says, flowing through the Grand Canyon, the Colorado River provides a puzzle as to its stage of development. The river shows the wide looping meanders characteristic of an old-age river. However, the valley walls are steep and V-shaped, characteristic of a youthful river. How might this apparent conflict of characteristics be explained? See, steep sides indicate it's fast-moving. Looping back and forth indicates it is slow-moving. And they wonder, how did that river make that canyon like that? Well, the river didn't make that canyon. Here's an aerial shot of Mississippi River, looping back and forth. Oftentimes, the loops actually get pinched off, and it flows straight across, leaving the loop behind. So now you got a problem. If on the right side it's Illinois, and on the left side it's Missouri, now a loop gets cut off. Who gets the loop? There's new farmland created. Is it in Missouri on the Illinois side of the river now? Take a close look at a map sometime. All along the Mississippi River, you'll see many areas that are colored to go to the state on the other side because it used to be there. I think they finally now, most states have kind of made an agreement. Okay, now regardless of what the Mississippi does, this county, this property here belongs to our state. You know, they pretty much have settled most of that. But it becomes a real problem if you happen to be living on one of these meanders. When it cuts it off, the lake that's left behind is called an oxbow lake. Who cares? Okay, that's the kind of stuff you study in earth science. Steep sides, though, indicate the river's probably very young or on high sloping ground, rapid sloping ground, so you get a steep sides to the river. So those would be a good quiz questions. Characteristics of a low gradient, meaning not very steep ground, stream are, the characteristic is that it's looping back and forth. Characteristic of high gradient stream is steep sides on the river. Grand Canyon has both loops and steep sides. And they can't figure out how it formed because they're assuming that the river made it. And the river didn't make it. The flood made it. This is from the phenomena of liquefaction we mentioned earlier. We had an earthquake in Japan. When the ground shakes, a lot of the water comes to the surface, and the whole surface of the ground becomes like putty. And the buildings sank in. See the building on the far right with the arrow pointing to it? The top is to the left. It is leaning over 60 degrees. That'll be tough to put the dishes away in the cupboard. Building number 3 there is leaning over pretty good. I mean, how do you fix something like that? Jack it up, right? Liquefaction causes the ground to become like soup. In San Francisco, one of the biggest worries they have is the next big earthquake. It's not going to hurt the folks who built on the mountains as much as those that built on the fill. See, for years, you want more property is expensive out there, so they build a dam, fill it full of dirt, pump all the water out, fill it full of dirt. You have new property. Like in Holland, you know, build a dike, pump all the water out. Well, in Holland, they're building a dike and pumping the water out, exposing new farmland that is below sea level. I guess that's not as much of a problem, but if you build a dike, pump all the water out, and then fill it full of dirt, all of that fill dirt is going to turn to soup first time you shake it. And in San Francisco, they have that problem, and other places, when the dirt just the fill dirt turns to soup and buildings sink right in. Here's the Alaska earthquake, 1964. It shook the ground horribly and split the city of Anchorage just about in half. I stayed in a hotel 30 feet away from where the fault line was. You could look out the window down and see the ground actually dropped down 30 feet. The hotel's built about 30 feet away from this place. They just smoothed out the dirt and planted grass. There's a hill right there. They said, oh yeah, this used to be up here back in 1964. This part sank down. You know, some places went up 60 feet just in a few minutes. Split a house right in half easily. You can see the earthquake, little damage here to this place. Mount St. Helens, though, did a great job of showing us what damage can be done very quickly by things like volcanoes and earthquakes. It's a natural disaster. On May 18, 1980, the volcano began to swell on the north side, which is the side to the right on this picture. It swelled up about 100 feet. They had been watching it and said, folks, this volcano is going to blow. Get off of here. And they went around getting people off the volcano, or telling them they should get off. 60-some people did not listen and died when it finally blew. But there were many warning signs. This volcano is going to explode. Instead of exploding like a normal volcano, the whole north side, which is on the right here, slid down. As all this massive amounts of material slid down, it, like pulling the cork off of a bottle of pop that you shook up real bad. Shake it up, get it full of pressure, and then pull the cork off. Things come flying out. The problem is it flew to the north instead of straight up. Ash and steam began coming out of the volcano as, at the same time, the side is sliding down. Enormous amounts of rock and debris sliding off the side. All this mud and rock and everything slid down, and ash began to come flying out. Ash and steam. As the steam and ash came flying out of this volcano, it made a massive cloud. A photographer was taking pictures from, I think, about 10 miles away. He's taking pictures, click, Click, and all of a sudden the ash cloud is going about 100 and some miles an hour, started going over the top of him. And he realized, man, I better get out of here. He barely made it out with his life. Many people did not. Here's a car covered up in ash. The ash landed all over all of the United States, basically, or huge areas from this little volcano. Here's a satellite view showing the ash cloud. Mount St. Helens at the far left-hand upper corner there. Lots of the ash landed in Idaho and all across southern Washington. This light yellow area shows where they got from a trace up to a half inch of ash from that one little volcano. Some areas got up to 5 inches. My sister lived north of the volcano. Now, it blew to the north, but the wind caught it and blew it to the east. The volcano erupted toward the north, and the wind blew it toward the east. Some of it landed in New York City. Some of the ash did. It affected the weather patterns for quite a while. But you can see the spot there in Oklahoma where quite a bit of ash landed. That's interesting. Probably one of the things that caused that would be what's called the Coriolis patterns, Coriolis effect. As the Earth is spinning, hot air is rising and cold air is sinking, and they're actually up and down circular currents to the atmosphere that are hundreds and hundreds of miles wide. So the air rises off the equator, being hotter, sinks at the poles. If it weren't more complicated, then you just get a big circular pattern of air. It'd sink at the poles, rise at the equator, and life would be simple. The problem is, while this is happening, the Earth is turning. Confusing things. And there are several places at 30 degrees latitude and 60 degrees where it makes a mini circle. At the equator, because hot air rises, the wind is generally blowing toward the equator. Not always, but that's a general rule of thumb. Well, if you're sailing along in your sailboat, everything's doing great. When you get to the equator, all of a sudden, the wind stops. Within a few hundred miles of the equator, because now it's not blowing anymore, it's blowing up, which doesn't do your sailboat any good. And so many people, in the old days, the ships were stranded there. And there's a name for that. Anybody know what that's called? That area where there's no wind? The doldrums is the name for the no wind, but those latitudes are called the horse latitudes. Anybody know why? They were stuck there for so long with no wind, they would be rowing these massive ships. Or they put the little rowboats out there and tie a rope to the big ship. Okay, guys, pull. And they threw horses overboard because, you know, it's going to take them weeks to get through here, and you couldn't afford to feed them. You're going to run out of food for your people. Horse latitudes. Or they ate the horses. Mount St. Helens on the far right here is 1 cubic kilometer of ejecta, it's called. That's the material that was blown out. This would be the ash, lava, etc. Mount Tambora did 80 cubic kilometers. Mount Krakatoa is the, as far as anybody's aware, this would be one of the loudest noises ever on the planet. That volcano is in Indonesia, down near Vietnam. When it erupted in 1883, it blew the entire mountain away. It didn't just blow a hole out, it blew the whole mountain off. It's gone. It made a tidal wave that went across the Indian Ocean. Let me grab the globe here. The tidal wave went across the Indian Ocean, 2,000 miles an hour. Volcano erupted here in Indonesia. The tidal wave went all the way across the Indian Ocean and hit this island, Madagascar, a 90-foot tidal wave. People are over here. Absolutely no warning whatsoever. All of a sudden, a 90-foot wave comes in. What's that going to do to the folks that live along the beach? Going to make a problem, right? Killed, I think, 36,000 people on Madagascar. No warning whatsoever. When that happens, that's called a tsunami, T-S-U-nami. Japanese word for big wave, I guess. I don't know what it's for. But there's a misnomer. Some people call it a tidal wave. It's not technically a tidal wave. A tidal wave is caused by the tide, okay? But we call it a tidal wave. Actually, it's a tsunami that's caused by an earthquake or a volcano. Rapid movement of the earth sends this wave out very rapidly. And people in San Francisco in the earthquake, the ones that survived, one guy, his testimony, he was up in a real tall building looking out the window, and the ground began to wave. Just he thought he was on the ocean because the ground itself is waving up and down. And he could see it coming toward him. All of a sudden, his building began to shake and broke and fell down. And he happened to survive. Okay, who cares? The ash blown out of Mount St. Helens was pretty interesting. The mud and ash and steam were the big problems from this volcano. Here you can see a picture of a mud slide sliding down the side of the volcano. This rapid mudslide did enormous damage down there. I've been to it a couple of times since it happened. It tore trees up like they were nothing, toothpicks, and boulders and trucks and everything moved down in this mud flow. Here's a semi that got caught in the mud flow. Boss is going to be mad about that, I can tell you right now. Looks like the semi is parked up against a motorhome. The guy came home to visit. I went and visited an A-frame house, which the people just had almost done, ready to move into. And the mud flow came down the river and filled their house halfway full of mud. They just abandoned it. If you ever go to Mount St. Helens, you can stop on the road up there to Mount St. Helens. You can stop and see the A-frame house. It's still there, half full of mud. Probably for sale, cheap. Okay. Here, this picture in the center, you can see Mount St. Helens, crater with lava dome. To the left, the little insert there is what it looked like before the eruption. The rest of the picture is what it looked like after the eruption. I want you to notice Spirit Lake. Can you see that on there? The before and after pictures of Spirit Lake. It actually raised the entire lake. I forget how much. All this stuff is on Stephen Austin's video, which is excellent, about Mount St. Helens, because he did just enormous studies on that. But the pyroclastic flows there, the volcano flowed to the north and then went to the left and blocked off the river. It blocked off an entire valley, just filled it up full of mud. Here there was an established drainage pattern. All this water is draining through there for years. Now it's all of a sudden has nowhere to go. The hot mud flowed right over blocks of ice that had been blown off the mountain. Mount St. Helens, before this happened, had glaciers all over it, just like Mount Rainier does. And when I climbed Mount Rainier, they said there are 13 glaciers. We climbed right across several of them. Nisqually Glacier, and I forget the name of them now. But these things are 200 feet thick, solid ice. Well, chunks of ice as big as this building were blown down into the valley when Mount St. Helens blew. Then all this hot mud flows over the top. Well, hot mud on top of ice is going to create a problem. Ice is going to melt, turning to water. It's going to shrink 12%. Then it's going to turn to steam, which means it's going to expand 1,700 times. That's how a steam engine works. Drop of water turns to steam, enormous pressure, pushes the piston, turns the wheels, whatever you're trying to do with it. This hot mud over the top of these blocks of ice created a problem. The ice began to explode as it tried to expand under the hot mud. There were explosions that were so loud, people thought the volcano was erupting again. After the explosion, the ice explosion, there would be a pit there, which everything would slump back in. All around this steam explosion pit, you can see erosion marks. Now, I guarantee some teacher's going to take his kids here someday, and now, kids, this took, he's going to say, kids, this took thousands or millions of years to form. No, this took about 15 seconds to form. Didn't take thousands or millions a year. The river system formed in 9 hours. The whole river, after it got blocked off, the landslide of May 18th buried the river and highway to Spirit Lake to an average depth of 100 feet. It also buried most other drainages in the 23 square miles of Upper Toutle Valley and plugged the valley's mouth. For 22 months, water had no established path to the lower waterway. Then on March 19th, 1982, almost 2 years later, an eruption melted a large snowpack that had accumulated in the crater over the winter. The waters mixed with loose material on the slopes of the mountain, creating an enormous mud flow. In 9 hours, while no one watched, the mud flow carved an integrated system of drainages over much of the valley and reopened the way to the Pacific Ocean. The drainages included at least 3 canyons 100 feet deep. One was nicknamed the Little Grand Canyon of the Toutle because it was a 1/40th scale model of the Grand Canyon. There are quite a few different Little Grand Canyons, okay? There's a Little Grand Canyon in Georgia. We talked about that last class. There's a Little Grand Canyon in Pennsylvania. There's a Little Grand Canyon in Washington State. This river was blocked off when it finally got deep enough to go over the top, it began to carve out canyons, gullies, in a hurry. This canyon formed in just a few hours. It's 1,000 feet wide, 140 feet deep, 2,000 feet long. Once water starts going over a dam, erosion can take place very, very quickly. There's a Grand Canyon in Yellowstone National Park, Wyoming, another little Grand Canyon, I think they call it. That probably formed in a couple of hours as the flood went off. Didn't form slowly over millions of years. In the sides of these canyons, you can see layers of rock. Here's the drainage pattern that the mud flow did in 1982 in Mount St. Helens. Here's a person standing on the edge looking down into this massive canyon, which formed just in 9 hours. At the bottom, you can see a person down there for scale. Above her head, there are all sorts of layers. Now, all of these layers were formed quickly as the mud flowed in, and the canyon formed quickly as the water washed through. I guarantee you some teacher's going to bring his kids here someday and say, boys and girls, each layer is a different year, so this represents thousands of years of accumulation. No, this represents, a few minutes of a mud flow. There's a little river at the bottom of this canyon. And if you think that little river made that big canyon, you are mistaken. And if you think the little Colorado River made that big canyon, you are just as mistaken. It didn't do it, okay? These things are evidence of a massive flood. The trees that were blown down by Mount St. Helens was pretty impressive. It blew so many trees down, loggers went in there to pick up whatever logs could be salvaged. When I was there, in 2000, what month was I there? Doesn't matter, I was there. Here it is 20 years after the eruption. I went up to see Mount St. Helens again. There are still thousands and thousands of trees laying all over. Been there for 20 years, got blown down. The trees flowed into the river, many of them, and blocked off rivers every place. Here are some semi-trucks next to some of these big logs. And if you've never been to Washington or Oregon to see the huge trees on the western coast of the United States, you won't know what I'm talking about. But those trees are enormous. Brother Pratsuk, did you live on the west coast, California or Washington? You never lived there, did you?
I just was over there.
You were over there. You didn't live there. Okay. These are enormous trees. There's all sizes up there, but loggers went in there to pick up the trees. And I've heard different numbers, but several people have said, yeah, they think they picked up 900 truckloads of trees every day for 7 years and only got 10%. I sat by a guy in the airplane flying back from Seattle one time. I was preaching out there. I said, what do you do for a living? We're going to be together for 3 hours, so I always talk to people on airplanes. He said, I work for Weyerhaeuser Lumber Company. I'm one of the vice presidents. I said, really? I said, did Mount St. Helens affect you guys? He said, yeah, we lost, I forget how many hundreds of acres of wood got blown down. I said, well, what'd you do? He said, well, we went in there to salvage whatever we could. We paid to plant all those trees, and we've been harvesting them for years. He said, it's very interesting. The government owned quite a bit of the property, and we owned quite a bit of the property. The government said, we're going to let nature take its course. We're not going to touch it. They left theirs. Weyerhaeuser and other paper companies and lumber companies went in there, picked up all the dead trees, planted new trees right away. Today, on the privately owned land, the trees are 20 feet tall and doing very well. Established forest, okay? Many of them 30 feet tall. On the government land, because they didn't plant right away, they just said, let nature take its course. The topsoil eroded off. Now they won't even start growing. Their trees are 2 or 3 feet tall. The ones that in many areas are ruined. Leave it to the government to mess things up, right? Here you can see at the very bottom the crater Mount St. Helens made. That's the way it looks today. Then at the top you can see Spirit Lake. Off to the left is this debris deposit where all this mud flowed in there. In Spirit Lake, there were possibly 1 million, certainly many, many thousands of trees that were blown into the water. You could actually walk across the water on all these logs. And Spirit Lake is a huge lake. Here you can see the logs floating in Spirit Lake. There's a postcard from Mount St. Helens in the background, still smoking just a little bit. My brother-in-law is a pilot. We flew down inside the volcano, flew around, smells like rotten eggs, the sulfur coming out of there. This was a couple years after the eruption we went down in. The trees will drift back and forth. Some days the wind is blowing one direction and blows them to this side, and a week later it blows them to the other side. This massive log mat, 2,000 acres, is floating around in this lake. Still there today. 20 years later, they're still there, some of them. Thousands of the trees began floating in the upright position. Here's some upright floaters, and they begin to sink to the bottom. As they get soaked full of water, they sink down. Scientists estimate there are 20,000 trees at the bottom of Spirit Lake. Many of them are already buried 15 feet deep, and they're standing up. None of them grew there. But it looks like they did. Looks like a forest. But there are no roots, just little stubs of roots because the trees was yanked out. After the break, we'll talk a little bit more about the trees in Spirit Lake and try to finish this section on the flood in the days of Noah. Let's take a little break. See you in a minute. Okay, let's continue here on Mount St. Helens and the damage it did. They estimate that Mount St. Helens was the same as an atomic bomb going off every second for 9 hours. And it's a small volcano by volcano standards. There have been some really big ones since then. Okay, these trees are floating in the bottom, or floating to the bottom of Spirit Lake. They settled out by species, which was very interesting. The Douglas fir trees would settle out the same time. Later, the pine trees would settle out. Very interesting the way they settled, because the wood density would be similar for these different species of trees, and so they would absorb water at roughly the same speed, and so they would settle out in layers. It looks like there was a forest of pine trees. Excuse me. It looks like there was a forest of pine trees, and then there was a forest of Douglas fir trees, and then a forest of something else because of the way they settled out into layers. But it's not. It gives the appearance of being a forest when it isn't. That's what we see all over the world. Here's some tree trunks in Athens, France, where there are petrified trees running through multiple layers, and some of the trunks are upside down. Those trees did not grow there. All over the world we find petrified trees in the vertical position extending through many rock layers. California near Santa Barbara has lots of them. Also, fish fossils in Santa Barbara extending through several layers of algae fossils. You can read the text there from a Bob Jones Earth Science textbook. Here. You guys were in Santa Barbara. Yeah. Along the beach years ago, there was a large number of petrified trees, vertical, exposed. As soon as they're exposed, the next thing is them to fall off. The beach erodes back a little bit. So they're never exposed forever. I mean, I'm not aware of any. They get exposed and then they fall down, and the beach keeps eroding back. But petrified trees standing up are pretty common. We covered that earlier in Seminar Part 4. Here's some from Joggins, Nova Scotia, where there are scores of them. Here's the St. Etienne, France picture. I'm showing many vertical trees running through many different layers of rock. Now, the textbooks are going to say each of those layers is a different age. Here you have proof positive they are not a different age. Some of the trees have root stubs, as if the tree was jerked out, broke all the roots off, and then was redeposited. Exactly what is happening at Mount St. Helens. The standing petrified trees in Yellowstone National Park are very interesting. There's one place, when I was up there, you can see me standing next to one here, one place where there are 27 consecutive layers of petrified of layers containing petrified trees standing up. 27 consecutive layers. The evolutionists have always said, see, these trees average 500 years old apiece, because they count the rings, petrified wood. So they'll say, you see, this layer here had to be here for at least 500 years, and then sediments came in, new forest grew on top, and that lasted 500 years. And then sediments came in, and a new layer on top, and you take 500 years times 27, that's more than 6,000. That proves the Bible's wrong. That's their logic. Now, slow down just a minute. What if all of those trees were 500 years old? When the flood came, they all settled out into layers, and this all represents one flood. Now, it doesn't prove the earth is more than 6,000 years old. These are pretty common to find these petrified trees all over. Here's the Specimen Ridge, Yellowstone National Park. 27 consecutive layers. They don't have any roots, or little root stubs maybe, but no complete root systems under these trees. And oftentimes they extend up into layers above it. And you could put 2 and 2 together and go through and find layer 1 and 2 and 3 are connected by this tree. Layer 3, 4, and 5 are connected by another tree. And layer 4, 5, and 6 are connected by another one. By going through and putting the pieces together, you could prove easily all of these layers formed at the same time. If the tree ever falls down, let's say you get a tree petrified, standing up. Years later, the dirt washes away from around it. Now it's going to fall over, right? When it falls over, it's going to break. Petrified forests all over the world are often with trees laying down, and they're broken up into logs. I don't know if you've ever cut down a tree for firewood or not, but when you cut a tree down, it does not break up into logs for you automatically. How many notice that phenomenon when you cut the tree down? Okay, let's see. Can you, under the screen, is that one wrapped in plastic, that big piece of petrified wood? I'm tied into a microphone here, but if you could bring me that one. That was just given to me here 2 days ago, was sent to me. I saw it a few weeks ago. The guy that sent it to me has a letter with it. This is pretty fascinating. I've been wanting to get one of these for my museum. The large one, yes. I know it's pretty heavy. And take that paper. Yeah, the letter too. Yes, sir. He said, Brother Hovind, I have some petrified wood that has chop marks on the end of it. This tree was chopped down. I said, man, I would love to get one for my museum. And you can see, looking on the end of this log, here's the letter the guy sent me about the petrified log. Thank you, sir. Where it was chopped down with the hatchet marks on the end. There's another one down there on the floor. This wood, he's got the story here. This site was harvested in the 1950s, from 1958 to 59, and this is apparently a log that got left behind and happened to get covered up with mud and petrified in less than 30 years. He said they replanted it with pine, because they had harvested the hardwood, oaks and stuff like that. They replanted it with pine. The men unearthed this log under a few inches of earth by accident when dragging out the logs. The men who did this were James Lloyd and L.D. Ford, who still live in the area, although their fathers have since deceased. This is from Knoxville, Tennessee, Memorial Baptist Church. Sent me this here just a couple days ago. Don't want to sit and hold that for the whole class period. So that's one of the strange things we get around here. This is from Bob Easley in McDonald, Tennessee. If you don't believe me, his phone number is 865, can't read it here, 573-8061. Call him a liar if you'd like, but he was there, you were not. Okay. These petrified forests are pretty common. I've been to many petrified forests, one in Florida, Mississippi, all over Arizona, Texas. There's mountains of petrified wood. Petrified wood, I think, happened because of the flood. Had to be buried relatively quickly in order to petrify before it had time to rot. This picture shows a couple scuba divers getting ready to go scuba diving under the log mat floating in Mount St. Helens, in the river, in the lake there, Spirit Lake. You can see the tops of their heads at the bottom of the picture there. They're going to go scuba diving under these logs. They notice, of course, the logs are floating back and forth in the lake, rubbing against each other, which is going to do what? Take the bark off. Exactly right. At the bottom of Spirit Lake, when they went down there, there was a layer of bark 3 feet deep. 3-foot thick layer of bark. How'd that get there? From the trees that were floating over the top, right? Coal can form in just a few hours. There's an article in Chemical Technology in 1972 about how to form coal in a few hours. Argonne National Laboratory showed that coal can form by heating wood, clay, and water for 36 weeks to only 150 degrees. If you get higher temperatures, it forms faster. During the flood, you would have massive log mats as big as Texas floating around because huge forests were uprooted during this flood. they'd float around for months. As they floated across the ocean, it would leave a debris trail behind it. Sticks, leaves, limbs, logs, bark. That debris trail is going to turn into coal. Coal is almost always found in layers, best explained as being a sedimentary deposit put down during the time of the flood in the days of Noah. This picture from a textbook, or from Reader's Digest here, is what is called karst topography. On the left, you can see the caves form in limestone. The earth does have many layers. That's not the question. The question is, how did it get that way? And I think the flood is the best explanation. To the right at the bottom, you can see the plume sticking up into it. Sometimes there are salt plumes. Sometimes there are sand plumes extending right through the layers of rock, distorting them. And you get into all that in earth science class, which is fascinating. I debated a lady, I debated a woman named Dr. Eugenia Scott, who is the president of the National Center for Science Education. Watch that name, because they're the ones who, they were founded by Carnegie back 100 years ago, I think. Their purpose is to keep creation out of schools. That's why they exist. During the debate, she said to me, she said, Dr. Hovind, there are 80 separate layers of coal in the Midwest. She's right. She said, if you look at the amount of coal in the world, the entire biomass of the world today could not be converted to that much fossil fuel. She's right again. What she's saying is here, there is so much coal in the ground, there aren't enough trees today to make that same amount of coal. Take every tree and bush in the world, smash it, you can't make the coal we have. Okay, what's your point? She said, see, this proves there had to have been an enormous amount of time involved in the laying down of the coal seams. Now, where's the flaw in her logic? Trees were bigger before the flood. A lot more of them. Knocked down by the flood. One more really major factor. How many trees are growing now in the Pacific Ocean? More land mass, sure. More land area, you get more forests. Period. Yeah, no polar caps, no deserts. You know, a lot more area, land area to support this kind of thing. Creation Magazine had an article in 1997 about coal seams. They're drilling down, they hit a seam of coal, they dig the coal out, dig down through some more rock, find some more coal. And they'll say, oh yeah, this one is millions of years older than this one. As they're mining this coal, they found out they come together. Now, what does that say? Formed at the same time, right? The area in between the two coal seams would be called a lens. You can get an ice lens, you can get a rock lens, you can get a coal lens. It's an area of, you know, like a lens for your glasses or something like that. The branching coal seams prove those layers formed all simultaneously. Here's Dr. Don McDonald, a friend of mine from Troy State University, and here's his phone number. That's him standing there to the left, next to a petrified tree standing up, running out of a seam of coal, through, I think, 20 feet of rock, into another seam of coal up above. Tell me those layers formed millions of years apart. They form rapidly. Here, straight above this hammer, you can see a branching coal seam, a small one. Oftentimes, coal is in real tiny seams, and it's still coal, but it's just not worth going after. Too expensive, not enough there to get. They look at the factors, you know, how much is there? In Wyoming, there's a place where it's 200 feet thick. I just read last week, I didn't document it yet, I'm going to go check it out, but I'll verify it before I put it in my seminar permanently, but that they found a coal seam 500 feet thick. Solid coal. That's a lot of coal. Sometimes in coal, strange artifacts are found. This is a bell found inside a lump of coal. Newt Anderson found it. I called him. There's his phone number back in '98. I talked to him again 2 months ago. He's got this thing sitting on his desk. Here he was about 12 years old or something back in West Virginia. He breaks open a lump of coal, and there's a bell inside. There's a strange little thing on top, some kind of deity, it looks like. Who knows, you know? Yeah. Don't know what it is. This zinc and silver vessel was found in solid rock, supposed to be 600 million years old. No, this is pre-flood, not pre-Cambrian. What appears to be a spark plug was found encased in solid rock. This was in California. From Reader's Digest, Mysteries Unexplained. In Alancha, California, in Owens Lake, they found what looked like a geode. When they broke it open, it looked like a spark plug inside. So they x-rayed it. There's the x-ray of this geode. Let's just read this here. What appeared to be a standard geode was picked up near Alancha, California. Fossil shells encrusting its surface are at least 500,000 years old. Yeah, right. This object came to be known as a COSO artifact. COSO. The names of the people who found the artifact were Mike Sull, whoever they are. Okay, they found it in 1961 on a mountain peak, 4,300 feet high, 340 feet above the dry Owens Lake. Geologists think that about 1,000 years ago, Owens Lake was as high as the top of that peak. Currently, no professional scientist has ever investigated the artifact. Even though it is found to be magnetic, it's quite similar technologically to a modern-day ceramic supercomputer capacitor. June 11th, 1991, Mrs. Culp found a gold chain inside a lump of coal. One year when I was up visiting my brother who lives in Illinois, that's where I grew up, I got the phone books and called every Culp in Illinois, trying to find out what happened to this thing. Who has the gold chain? I found out some people who said, oh yeah, I remember seeing that. I knew about that. Grandma had that. I don't know where it went. Last time I saw it was 1959. So if you watch the tape and you're a Culp, please find out for me who the culprit is that has this thing. Because I would like to buy the gold chain for our museum here. A carved stone was found in solid coal in Webster, Iowa. A stone somebody had obviously carved on. Daniel, behind the curtain again, I hate to keep sending you back there, is a replica of this iron pot found in a coal matrix. If you could grab that. It's on about 4 shelves up. See, it's kind of a dull black. Can you reach it there? They make copies of this. Yes, sir, that's it. Thank you, sir.
Is that Wyatt's museum?
No, this creation evidence is Carl Baugh's museum in Texas, okay? Glen Rose, yeah. This is the replica that they're making of the artifact as it was found in solid coal. It's an iron pot, apparently used for, melting small objects, to pour them out into something else. Now, how could you explain a human artifact in a lump of coal? Must have been a human before the coal was formed. And that would be people before the flood. American Weekly, 1922, ran this article. New York Sunday American. The sole of a shoe from Nevada. The stitching pattern was clearly visible, including the twist of the thread. The rock was 213 to 248 million years old. Now, Michael Cremo, who wrote this book, Hidden History of the Human Race, is a Hindu. I've talked to him several times. The book is excellent, by the way, on strange things that are found out of place. Michael Cremo spends an enormous amount of time documenting things that are found that shouldn't be there. But he believes the standard geologic column. He really believes that rock is 200 million years old. So, the conclusions he came to is aliens visited the planet 200 million years ago. Why not question the idea that the rock is 200 million years old? Why do you accept that and come to these wild other conclusions? When they found dinosaurs, when Mackall went to Africa, said there are dinosaurs still living in Africa. He came back and said, it's amazing they survived for 70 million years. The thought never entered his mind, hold it, maybe your whole theory is baloney, okay? Genesis 8 says the water assuaged. This is a very interesting word. The water did not just go down or dry up. What happened to the water after the flood? Well, next week we'll talk more about what happened to the water after the flood and try to finish up what's on our videotape number 6. Then we can get into the question and answer session on carbon dating and stuff like that coming up next.